So in problem 10, we want to graph this linear equation, 6x minus 2y equals 12. And notice the form, the variables are on the left side, the constants over here on the right side, and these two coefficients, the 6 and the negative 2, divide evenly into the 12. So what we're going to do is use the intercept form, and we do that by creating a table with just 2 points. So let's do this. Let's let an x column and a y column, and let's choose 0 for x, easy number to work with. And if we put 0 in for x up here, 6 times 0 is 0, that whole term is gone, and we get negative 2y equals 12. Divide by negative 2, and we get negative 6, right? 12 divided by negative 2 is negative 6. Then, if we let y equal 0, now I'm going to put little stars here, so if I look back, I remember which one I chose, the x or the y. So if we choose y to be 0, I'll put 0 in here. Negative 2 times y is, negative 2 times 0 is 0. That whole term is gone, and I get 6x equals 12. Dividing by 6, we get y is equal to 2. So let's plot these 2 points. 0 and negative 6, that's down here. And 2, 0, right, 2, 0, that's going to be x equals 2, y equals 0 is here. And I'll try to draw a straight line through those 2 points. So that line looks something like that. So for problem 11, we'll do pretty much the same thing with problem number 10. Let's create, we need only 2 points, so we'll create our table. And notice we've got the right form here. The variables are on the left side, the constants separated, we're on the right. And these coefficients, 1 and 3, both divide evenly into 6. So this method, the intercept method, is a good method to use. So let's choose x to be 0, and if x is 0, put 0 in here, we get 3y equals 6. Dividing by 3, we see that y is equal to 2. And then if we choose y to be 0, right, we'll put 0 in for y. 3 times 0 is 0, that's gone. And we get x is equal to 6. So let's plot these 2 points. 0, 2, the first point, 0, 2 is right there, right? That's our point, 0, 2. X is 0, y is 2. And the second point is 6, 0. X is 6, y is 0. So 6, 0, that's going to be way out over here. So I'll try to draw a reasonably straight line through those 2 points. And there's our graph. Now, for problem 12, we're going to graph these lines. And notice that there's one variable here, so we get, remember what we said before is that if both variables appear, let's go back up here to number 10. If both variables appear, we get a slanted line. That's what we got in number 10. And over here in 11, we had both variables and we got a slanted line. But now in 12, we have only one variable appears in each equation. So what we're going to get is a non-slanted line. And that x equals 5, let's go over to x equals 5. Now, it's not going to be slanted. It's either going to be horizontal or vertical. The most reasonable kind of line to draw here is going to be a vertical line, because everywhere on this line, just pick any point on that line, what's the x value? The x value is 5, right? We're 5 units over. No matter what x you pick, no matter what point you pick, x is 5. Now, in problem 12, we're going to graph these 2 lines, and notice, because there's only one variable in each line, we're going to get a horizontal line and a vertical line. If you look back here to problem 10, we had both variables appearing, as we did in problem 11. In 11 and 10, both variables appeared, and we got slanted lines. So if both variables appear, you get a slanted line. But if only one variable appears, you get a non-slanted line, which means it's going to be horizontal or vertical. So let's take a look at this first one, x equals 5. Now, a reasonable thing to do is go over to x equals 5 here, and we're going to draw either a vertical line or a horizontal line. Let's draw a vertical line and see why that makes sense. On this vertical line, no matter where you are, place yourself anywhere on this line, what's your x value? The x value is 5. No matter where you are, x is 5. Notice there's no y here, so this equation is independent of y. That means it doesn't matter at all what y is. X is always 5. Now, for this equation here, y equals negative 3, let's go over to negative 3 on the y-axis. That's right here. We'll put a point there. And a reasonable line to draw here then would be a horizontal line. And our reasoning is this. No matter where you are on this line, no matter what the x is, what's the y? Y is 3. Negative 3. Y is negative 3 no matter where you are.